actually worked. Within a few hours, we discovered that plants indeed emit sounds, brief ultrasonic clicks, high above human hearing ability.
Artificial intelligence has opened a doorway into a hidden world that has existed all along. Scientists have discovered that plants use a form of communication, and once you hear it, it's impossible to unhear. Just minutes after oxygen levels fall, certain plants begin sending out urgent warning signals to those around them. For most of human history, we viewed plants as lifeless background elements, beautiful, useful, but ultimately silent. New research is proving the opposite. Plants are active participants in their environment, constantly sensing and responding to change. Almost no one knows this, but a thirsty tomato plant can emit distress signals up to 30 times an hour. These sounds aren't random. They're organized messages packed with information about danger and survival. We've always thought of the plant world as silent and slow, a calm, peaceful place where nothing dramatic happens. To us, plants are just oxygen factories and food sources. But here's the truth. Our senses are weak. And because of that, we've been missing the largest conversation happening on this planet. So, a group of researchers decided to listen in a way no one had before. They used ultra-sensitive microphones capable of detecting frequencies far beyond human hearing. These microphones were placed just inches from tomato and tobacco plants inside a soundproof chamber. At first, there was nothing. Total silence. Then the plants were stressed. When watering stopped, the quiet exploded into rapid clicking noises, sharp pops firing off one after another. These sounds landed between 40 and 80 kilohertz. For perspective, even someone with perfect hearing can only hear up to 20 kilohertz. In other words, the plants were screaming in a range completely invisible to us. Healthy plants barely make a sound, but a thirsty tomato plant can unleash up to 40 ultrasonic cries every single hour. And this isn't just air bubbles popping randomly. Artificial intelligence was used to analyze the sound patterns, and it worked. The AI could correctly identify whether a plant was dehydrated or physically injured with 84% accuracy. That changes everything. We used to believe plants simply reacted to the environment like slow-moving machines. Now we know they actively broadcast their internal condition. In nature, insects like moths, and even small mammals, can likely hear these signals from several feet away. A moth searching for a plant to lay eggs on might actually listen to see if that plant is already stressed and vulnerable. This exchange of information has been happening right under our noses for millions of years. And that's putting it mildly. We've essentially been standing in a room full of screaming voices without the ability to hear any of them. The AI also discovered that different types of harm produce different sound signatures. A cut tobacco plant doesn't sound the same as a thirsty one. Each form of stress has its own acoustic fingerprint. For farmers, this is a game changer. Imagine sensors that can tell you exactly what a crop needs before it ever starts to wilt. We could save billions of gallons of water by responding directly to what plants are asking for. But there's a darker implication. If plants can communicate pain, that suggests a level of awareness we've never acknowledged. Every blade of grass suddenly looks less like scenery, and more like a participant in its own survival. And beneath all of this noise lies something even more unsettling. For years, scientists have known that trees are connected underground by vast fungal networks, often called the Wood Wide Web. The popular idea was that this system was gentle and cooperative, big trees sharing nutrients with smaller ones. A peaceful forest community. AI revealed a very different story. This underground network isn't just for sharing food. It's a high-speed communication grid used for coordination and even chemical warfare. When insects attack a tree, It doesn't just defend itself. It releases bitter toxins into its leaves and sends an emergency message through its roots. AI analysis showed that these alerts race through the fungal network at incredible speed. Trees hundreds of feet away begin activating their own defenses before the insects ever reach them. The forest behaves like a single massive organism, with something resembling a shared nervous system. But it doesn't stop there. This network isn't always friendly. While we love to imagine nature as cooperative, AI uncovered evidence of sabotage. Certain trees, like black walnut, use the fungal network to distribute toxic compounds that prevent competing plants from growing nearby. They are actively poisoning the soil to eliminate rivals. The AI detected low-frequency signals coordinating these chemical attacks. It's a slow-motion battlefield where plants fight over space, water, and sunlight. They spy on their neighbors, wait for weakness, and strike when the moment is right. This level of organization is one of the most shocking discoveries in modern biology. It means forests aren't just collections of trees, they're societies. They share when it benefits the group, and they can be brutally ruthless when it doesn't. We're talking about a biological internet that predates human technology by millions of years. A world of alliances and betrayals unfolding silently beneath our feet. But the most disturbing discovery comes when humans enter the equation. We always assumed plants were unaware of us unless we touched them. After decoding their communication, scientists decided to test something that feels straight out of science fiction. Two people interacted with the same group of plants. One was a caretaker, watering them and tending to their needs. The other was an aggressor, cutting leaves with scissors. AI monitored both the plant's electrical activity and their ultrasonic sounds. What it revealed was absolutely shocking. At first, the plants didn't seem to care who entered the room. Both people triggered the same neutral response. But that changed fast. Within just a few days, the AI detected something strange. When the caretaker stepped inside, the plants remained steady and quiet. But the second the aggressor crossed the threshold, the room exploded with ultrasonic crackles. Nothing had been touched yet. No leaves cut. And still, the plants reacted. They were identifying the person before any physical contact, responding to the rhythm of their footsteps, the subtle vibrations in the floor, even the chemical fingerprint of their scent. The AI revealed something almost impossible to process. The plants had formed a memory. They knew who was safe and who was dangerous. This is where it gets unsettling. Plants don't have brains, no neurons, no central nervous system. And yet, they can store information, recognize patterns, and learn from experience. The AI was able to predict which person was entering the room purely from the plant's electrical activity. That means plants aren't just reacting in real time. They're using the past to prepare for the future. It raises a chilling question. What if the tree in your backyard remembers you from a decade ago? And it doesn't stop with people. The data showed plants panic at the sound of machines. Lawn mowers, chainsaws, heavy equipment. Long before the blade ever touches grass, plants detect the sound from a distance and erupt in distress signals. A wave of alarm ripples across the lawn. Grass warns grass. Roots alert roots. They're screaming to each other about what's coming. We move through a world that isn't just alive, but constantly evaluating whether we are a threat. And plants don't stop at fear. They fight back. Once scientists realized plants could identify danger, the next question became unavoidable. Can they retaliate? Using AI, researchers cross-referenced plant communication patterns with environmental shifts and human health data. What they uncovered sounds unreal. But the numbers don't lie. Plants aren't just suffering from climate change. They're responding to it, strategically. The AI detected massive forests synchronizing the release of airborne chemicals designed to increase cloud formation. In simple terms, forests appear to be attempting to cool themselves by altering the weather. But here's where it turns darker. In heavily polluted or over-harvested areas, plants are producing pollen that's noticeably more aggressive. The proteins have shifted, becoming more irritating to human lungs. It's almost like a biological deterrent. The global surge in allergies and respiratory issues might not be random. It could be a coordinated pushback from a kingdom that's reached its limit. Even more shocking, plants are sharing these defensive upgrades. When one group develops resistance to a toxin or chemical threat, that information doesn't stay local. The AI found evidence that plants use fungi and viruses to exchange snippets of genetic code across long distances. That explains why weeds adapt faster than science predicts. They aren't evolving alone. They're crowdsourcing survival. This is teamwork on a planetary scale. The soil itself is becoming hostile. In places like the Amazon, native plants appear to encourage fungal growth that selectively destroys industrial crops while leaving the forest untouched. A microscopic army doing silent damage. Plants aren't waiting for us to change. They're actively undermining our control. We thought we were running the game. But the planet has been playing a far deeper version of chess, using chemistry, genetics, and time as its pieces. And this struggle isn't limited to one forest or one continent. It's global. When scientists stepped back and analyzed a decade of cumulative data, something terrifying emerged. For centuries, we believed Earth was a quiet stage for human activity. But when deep learning AI was combined with unsettling ASA's hyperspectral satellite imaging, that illusion collapsed. This planet isn't silent. It's screaming. Researchers were originally tracking carbon storage and moisture levels. Instead, they uncovered something no one expected: global biological synchronization. When a massive wildfire erupts in the Amazon, or chemicals spill into the Yangtze, distress signals ripple across the planet in seconds. Not hours, seconds. The AI identified a biological pulse. When redwoods in California dry out, moss in the Siberian tundra shows matching electromagnetic spikes. It's as if Earth's vegetation functions as a single, interconnected nervous system. This isn't trillions of isolated life forms. It's one vast intelligence, fully aware of its own condition. But that raises an impossible question. How does the signal travel so fast? Root systems and fungal networks are too slow to explain it. That's where one of the most controversial theories comes in: the atmospheric carrier wave. Some scientists believe plants may be using Earth's magnetic field and ionosphere to transmit information by subtly modulating the electrical charges produced during photosynthesis. In other words, forests might be broadcasting their status into the sky. The AI didn't just find a pattern. It uncovered what looks like a planetary Wi-Fi network that's been running for millions of years. Under this theory, every leaf functions like a microscopic antenna. When a forest is destroyed, the signal doesn't just vanish. It leaves a detectable void. A silent gap the rest of the network immediately responds to. We've been living inside a non-stop planetary transmission, completely unaware the air around us is saturated with survival data. And if Earth truly operates as a superorganism, the implications are horrifying. In biology, when a pathogen damages tissue, the immune system activates, which leads to a brutal realization. We are the pathogen. For centuries, humanity has stripped the planet's skin, poisoned its bloodstream, and fractured its systems. According to the AI's translation, the global plant signal isn't welcoming us. It's an emergency alert. What the AI detected may be the sound of a planetary immune response entering overdrive. And some researchers go even further, suggesting that extreme storms, fungal outbreaks, and collapsing insect populations aren't random side effects. They could be countermeasures. A fever response. The planet may be trying to burn the infection out. This superorganism may be doing what every living system does when it's under attack, making itself hostile to whatever is killing it. A quiet war is underway. Chemical sabotage, carried out in silence. And now, an even more extreme theory is emerging where botany collides with neurobiology. We already know plants manufacture complex chemicals to drive off insects and grazers. But what if that strategy has scaled up? What if it's no longer local, but global? One idea, known as the nutritional decline theory, suggests plants are deliberately changing their chemistry to provide less nourishment, slower growth, lower energy, harder digestion, not a sudden collapse, but a gradual weakening of the species that depends on them most, a long, quiet famine. But there's an even more unsettling proposal, the cognitive interference theory. It suggests plants may be releasing airborne compounds designed to subtly influence human brain chemistry. If they can't overpower us physically, maybe they're trying to slow us down mentally, triggering fatigue, anxiety, reduced fertility, or loss of focus. We blame modern life for our stress, but what if the air itself is part of the equation? A chemical lullaby meant to quiet a species that refuses to stop expanding. A desperate signal from a kingdom asking us to pause, consume less, reproduce less. For our entire history, we believed we ruled a silent planet. We built machines, cities, and now artificial intelligence, assuming it would help us dominate nature even further. The irony is brutal. AI didn't make us masters of the earth. It became our translator. It didn't just crunch numbers. It heard the message. And that message is one of overwhelming distress. Plants are the first to feel rising heat, the first to absorb toxins falling from the sky. They've been recording the collapse of the system long before we noticed it. Our technology has finally reached the point where we can tune into the frequency of the planet's suffering. But the data suggests we may have started listening far too late. The question isn't whether forests are thinking anymore. The question is whether they've already decided we're expendable. One of the most mind-bending theories suggests plants experience time differently than we do. With lifespans that stretch centuries and lineages that trace back hundreds of millions of years, they don't think in moments. They think in cycles, in eras. Some researchers believe the global plant intelligence saw this crisis coming over a century ago. While humanity celebrated industry and progress, the green world was quietly adapting, altering DNA, burying seeds deeper, and preparing for a planetary reset. This theory doesn't say plants are trying to save Earth. It says they're trying to survive us. They may be planning for a world without humans, retreating, waiting, letting the infection burn itself out before reclaiming what's left behind. Even invasive species might not be accidents, but pioneers. Tough, fast-spreading organisms designed to fracture concrete, dismantle steel, and reclaim cities once we're gone. We are standing at a turning point. Now that we have the ability to listen, ignorance is no longer an excuse. The secret language of plants reminds us that we are a young, destructive chapter in a much older story. The signals are everywhere: forests, fields, lawns, and gardens. They all say the same thing: balance is broken. If we keep ignoring the warnings, we may eventually learn what happens when a planet's immune system fully activates. Earth is not a warehouse of resources. It's a sovereign entity with billions of years of evolutionary experience. We thought we were kings, only to realize the castle is alive. And it's not pleased. So the real question isn't whether plants can communicate. It's whether we're courageous enough to hear them and humble enough to change before the planet decides to erase the infection entirely. If the entire world is screaming at a frequency you can't hear, does that make the pain any less real? Do you think plants have already decided humanity is a threat that needs to be removed? What's the most terrifying thing a plant could say to us? Drop your thoughts in the comments, and don't forget to like and subscribe for more deep dives into the hidden world all around us. Thanks for watching.